Okay, hello, Upper Six. I'm just going to give you a quick demonstration today of the two different types of telescopes you need to learn about for A-level physics, the astrophysics option. You are going to have to learn the ray diagrams for these, and you're also going to have to be able to describe what the advantages and the disadvantages are of the two different types of telescopes. So the two main types of telescopes are refractors and reflectors. Refractors use a lens and reflectors use a mirror to gather the light. That's the main difference between the two. So what I've got set up here in the library are two small examples of each type of telescope. So I'm going to start off with the refracting telescope, which is probably the easiest one to understand. So this is a refractor, and the basic components of a refractor are the objective lens, which is the main lens that's at the front of the telescope. So if I point that towards the camera, you can probably see the lens in there. That's the objective lens. And the eyepiece lens, which is the small lens that you look through at the end. And that's basically it. So it takes the image from a very great distance away, would say infinite distance away, parallel light beams coming in to the objective lens. The objective lens will focus the light somewhere around here and produce an image of what you're looking at, and then the eyepiece will magnify that image for you to look at. So that's a refracting telescope. This was the earliest type of telescope that was invented, a chap called Galileo Galilei. Although he didn't actually invent the refracting telescope, he was the first person to use a refracting telescope to look at things in space. He looked at the moon and discovered craters on the moon. He looked at Jupiter and discovered the moons orbiting Jupiter. He looked at the sun and discovered sunspots on the sun, also the phases of Venus. So that's a very simple refracting telescope. You could buy a telescope like this, by the way, for about 70 quid. Okay, they're fairly cheap. What do you have to know about telescopes? Well, one thing you have to know is what's the point of a telescope? They're the most important astronomical instrument. Telescopes do two things. First of all, they magnify the object that you're looking at, which is kind of useful. So if you're looking at Jupiter on the sky, Jupiter just appears as a dot to the naked eye on the sky. But for a telescope, it expands it so you can see detail on Jupiter, like the cloud bands, like the great red spot, and so on. So that's magnification. Now, the size of the magnification does depend on the focal lengths of these two lenses. Now, the focal length of the objective lens is much bigger than the focal length of the eyepiece. And actually, the ratio of the two will give you the magnification. So if the focal length of the objective lens is 10 times the focal length of the eyepiece, the telescope will magnify 10 times. So Jupiter will appear 10 times bigger than it would do to the naked eye. In fact, for this particular telescope, the focal length of the objective lens there is 700 millimeters. This eyepiece here is about 20 millimeters, so 700 divided by 20. So that's about 35 times. So at the moment, with this particular eyepiece in, it's going to magnify 35 times. So that's one use of a telescope, is to magnify. In fact, that's not the most important use of a telescope. It's not like a microscope in biology. It has another use that's more important, and that's to make faint things seem brighter. If you think about your own eye, the pupil, which is the little hole in your eye which gathers the light, is only about 5 millimeters across. But the objective lens on this telescope is about 50 millimeters across. It's actually a bit more, I think about 70 millimeters across. So you can see the light gathering area of this telescope is much, much bigger. It's almost like a bucket that's gathering light. And the biggest telescopes in the world, well, the biggest refractor in the world actually has an objective lens that's about 40 inches across, which is actually about over a metre across. And the bigger the objective lens, the more light gathering power the telescope has, and it makes faint things seem much brighter. So stars that you can't see with the naked eye, you can see with this telescope. So two things that it does: it makes faint things look brighter and it magnifies images as well. The first thing is actually the more important thing, the fact that it makes faint things look a lot brighter. So that's basically a refracting telescope. As I said, you will need to learn the ray diagram for this and how it produces the image and how it magnifies it, and also using that formula to work out the magnification. So it's the focal length of the objective lens divided by the focal length of the eyepiece. So that's a refracting telescope. Over to my left here, we have a reflecting telescope. Now, reflecting telescopes were invented about 70 years after refracting telescopes. In fact, one of the most famous scientists who ever lived, Isaac Newton, was the chap who invented the reflecting telescope. Reflecting telescopes use a mirror rather than a lens to gather the light and then focus it. And that has a particular advantage. A lens, although it can focus light, has a bit of a problem because a lens will focus light of different colours or different wavelengths at different locations, which produces a problem with the image that you see, that the different colours of light get focused differently. So if you've got the red light in focus, the blue light would be out of focus. So what you often get with a refracting telescope is a problem called chromatic aberration, which is where you see a rainbow around the image that you're looking at. It's a defect really with refracting telescopes. The other problem with refracting telescopes is you can't make lenses that big. The biggest lens you can make, well, as I said, the biggest one in the world was 40 inches across. And in fact, it's so big that it's distorting itself and it's not actually useful for anything professional as a telescope. You can't make lenses that big, it's just an engineering problem. So the solution is a refracting telescope which uses a mirror to focus the light instead. Now this particular type of refracting telescope is called a Newtonian reflector. And the design of it is fairly simple. It's the same one that Isaac Newton made 300 years ago. It's got a mirror at the back, which is a parabolic mirror. The light comes in at the front. It hits the parabolic mirror at the back. The light then gets focused forwards onto, if you just want to bring the camera forward a bit and just point down there, it gets focused onto a little mirror that's inside, a secondary mirror, which is at a 45-degree angle, which is a plane mirror. And that then sends the light outwards here through an eyepiece. So you would look in the eyepiece at the side and the light would come in at the front. And this is a Newtonian reflector. And as I said, that has the advantage of you can make a bigger mirror, and also it doesn't have chromatic aberration, unlike a refracting telescope. There is another design of reflecting telescope you do need to learn about, and I haven't got an example of this to show you, but it's called the Cassegrain reflector. And a Cassegrain reflector, instead of the eyepiece being stuck on the side here, the eyepiece is stuck at the back, looking through a hole in the back of the mirror. So what happens is with a Cassegrain, the mirror reflects the light back to the front, and then at the front there is a little convex mirror that then sends the light back again through a hole at the back of the primary mirror, and then you view the image an eyepiece that's stuck in the back. So that's a Cassegrain reflector. This one is a Newtonian reflector. So there's basically three types of telescope you need to learn about: the refractor, the Newtonian reflector, and the Cassegrain reflector. The Hubble Space Telescope, by the way, the most famous telescope in the world, is a reflector. It's got a mirror. It did have a problem with its mirror when it was launched. The mirror wasn't completely the right shape, and so the image wasn't focused as sharply as it should have been. And they had to correct that by sending up a lens that fitted over the front of the telescope that corrected the image. So that's the Hubble Space Telescope. The biggest reflecting telescope in the world, until a couple of years ago, it was the Keck telescope in Hawaii, and it had a 10-metre wide mirror at the back. I believe that's now been superseded. I think there's one in Chile that's the very large telescope that's even bigger than that. But that's a reflecting telescope. The last thing I'm going to talk about very quickly is instruments. Now, small telescopes like this, people would look down an eyepiece at the end, but professional astronomers don't sit in their observatories looking down eyepieces. What they would do instead is they would record the image on a detector. Now, in the old days, that detector used to be photographic film. In the modern era, astronomers use electronic recording devices like CCD chips to record images. Now, they're very similar to the chips that you have in your phone to record photographs and record videos. Your phone and your digital camera, they also have these CCD chips. In fact, I have got a camera here which is designed to fit onto a telescope. So this camera here is it's a Wi-Fi camera. So when it's connected, I can press a button and it sends it by Wi-Fi to a mobile device, the image, and I can record the image. If I get a chance, I may do a video at home showing you how this works, looking at the moon or something like that. But basically, inside here, there's a tiny little CCD chip. On the refracting telescope, this would just slot in here. So it replaces the eyepiece. It's a standard size, so it would just slot in like this. It would be sending the image to an iPad. I would have to focus it, and then you'd be able to record the image of the moon or Jupiter or whatever it is you're looking at on your mobile device. With professional astronomers with big, huge telescopes, obviously they don't have little cameras like this. The cameras will be huge. Quite often, for a reflecting telescope, the cameras would be located inside the reflecting telescope, and they would be put where the secondary mirror is here. So basically, the light would come in, hit the primary mirror at the back, be reflected forwards, focused on where the secondary mirror is there, and that's where the camera would be. And that's called prime focus imaging. So that's basically it. Okay, there is going to be some homework this week. I'm going to get you to draw some ray diagrams for these telescopes, and hopefully that'll be done by the end of the week. Okay, so thank you for that, and I'd also like to thank my cameraman here, John from Year 7, who's been recording this. So that's it. Thank you very much.